Okay, so we're going to solve another logarithmic equation that arises. We have our principal, $1,000 at 10% annual interest compounded annually. You've got $1,000 times 1.10 to the t. That's your function. P of t is this. So the question is, how long do we get $3,000? Well, kind of a no-brainer, but we want to write it out so we get the logic of our solution. We have $3,000 when P of t equals $3,000, because P of t is how much we have after t years. Okay? Now P of t is $1,000 times 1.10 to the t. So we want $1,000 times 1.10 to the t to equal $3,000. I want you to go through this logic. I want you to remind yourself of the logic and not just do this by habit and imitation. It'll stick with you better. You'll be more reliable when you take the final. Okay, so $1,000 times 1.10 to the t equals $3,000. How do we solve this? Well, we can start by using just basic algebra. We can divide both sides by $1,000. So we get 1.10 to the t equals 3. $3,000 divided by $1,000 is 3. So, using our rule here, of course we've got a t instead of an x, but that's not going to do us any harm. So it's going to be b to the t equals c. It's got to be equivalent to t equals log base b of c. It's an easy adaptation. So this is going to be equivalent to what? B is 1.10. Instead of x we got t, so we can write t equals log base b, the base is 1.10, of the number on the other side here, which is 3 in this case. And how do we get that? Well, we don't have a graph of the log of 1.10, so we're going to use the second rule. And we'll do log of 3 divided by the log of 1.10. And we're going to see what that's equal to. Now, looking at my graph, I expect that's going to be equal to maybe 11. Where the 11 is estimated from the graph. 11 is a reasonable result. You're going to get a more exact result, and you can round it down to the day if you want to. You round it down to the second. But it's going to be in years, so you got to convert your years, seconds to years and all that stuff. Okay. Yeah, years to seconds, I guess. Okay, but that's the process. And it wouldn't matter if you'd used natural log of 3 over natural log of 1.10, or with a good graph of the basic logarithmic function, the base 2 logarithmic function, the base 2 log of 3 divided by the base 2 log of 1.10. And I'll remind you what that looks like. Here's your base 3 log, or base 2 log, and the log of 3, well, you go out here to 3. And there we have it. and then you get 1.10. Now you know, if you understand this graph and how to construct it, and you should be obvious that here's the point where x equals 1. So x equals 1.1 is here, so that it's too small to even put an arrow on it. So you're going to have this small value here divided into this big value here. So here's the log of 1.10, or at least a graphical approximation. Here's your log of 3. How many of these does it take to make this? Well, it's plausible it takes about 11 of them, just the way I drew it. If you have a really good graph, you can make a reasonable estimate and also visualize the graph, and again check whether this thing comes out of your calculator makes sense. So that's a valuable thing to do. Now, we could also solve this if we consume continuous compounding. P of t is going to equal e to the 0.1 t. 0.1 being your interest rate, e to the RT. So, without writing out all the details of the reasoning, because I don't have room, we're going to solve e to the 0.1 t equals, sorry, 1,000. That was dumb. Okay, I have to squeeze it in there. 1,000 e to the 0.1 t. So we have $1,000 times e to the 0.1 t equals $3,000. And we divide both sides by the $1,000 because that puts this into the form of a b to the x equals c. So we get e to the 0.1 t equals 3. So now our exponent is no longer just a single variable, it's a 0.1 t. So instead of x we got 0.1 t here, instead of b we've got e, and instead of c we have 3. It helps to write that out. Okay? X is 0.1 t, b equals e, c equals 3. Jot that off to the side someplace so that you can translate it correctly and efficiently. Okay, so we get 0.1 t equals log base e of 3. Now I've told you that the base e log is the natural log, and you've got a button on your calculator, so you don't even have to use this one in the case where you have the e to the power. So I can just say that that's equal to the natural log of 3. So t is the natural log of 3 divided by 0.1, and that is 10 times the natural log of 3, and that equals what you get when you plug natural log of 3 into your calculator and multiply it by 10. Okay, and that's going to be 11 or 12. So I'll say that's approximately equal to 11, just the same as this was. But compounding continuously gives you more money, as you know from having done the preceding assignment, so that this number is going to be a little bit less than the number you get if you do this. And I'll be asking you to do these calculations. So that illustrates how you can solve exponential equations for a financial situation, for an investment or a deposit at a constant rate. And then you can extend that to other similar concepts like population and so forth. So you're going to have some problems to do this way. Fairly straightforward, and many of you have had analysis courses. I don't know that everybody has. Haven't checked what your specific background is. And you know, one problem is that maybe logs would be done late in that course and you might have more or less missed them because of the virus epidemic. So I don't know where people are, but I anticipate some of you will have seen this already, and the more complicated things you can do with exponential equations that we're not going to bother with here because you don't need them for the application that we're looking at. So there we have it.